Hi, welcome to another video on my Raspberry Pi 1 running Raspbian and using hardware based pulse width modulation. Last time I had to rewire a number of things and decided that I needed to put a transistor and resistor in the circuit to get this motor running. Still doesn't work, but I'm not sure without measuring if this circuit actually has current or voltage, and that is quite necessary for it to run. What I found out is that I had to rewire the motor anyway, because the plus has to come via the transistor and the minus has to come from here and not vice versa. That said, the order in which you put these connectors doesn't really matter. It just matters for the direction in which the motor runs. But anyway, this is a better idea, and if you keep red for power and green for the mass or ground, then you end up with this configuration, this being red and this being green. However, I'm still not sure there is any power on it, and I could measure it, of course, but the easiest way to do it is to move this jump wire a bit here, replace it with a smaller one, that too, and then put an LED in this location. So let's just do that. First, let's see if this is a better jump wire. I doubt it. So what I need to do with this one is making sure it starts right here. And now I'm not that happy with it because it kind of bends. So let's see if I can make it in a better way. Experience has told me that wires can break, so I need to be careful. Well, this is one thing, and then comes in this LED, which has tested to be working. Now, of course, the direction matters, and the correct direction would be like this. So if I switch on everything, meaning start the program, I should at least have a glowing LED, but will I? And I'm turning away the light and I see absolutely nothing. So the question is there power anyway on this line? And I'm afraid that the voltage is way too low for getting it over the transistor. So I have to measure anyway. So with the multimeter engaged, let's measure something. It's put to a limit of 2 volts direct current, and first of all directly on the pulse width modulation, and that's going to be hard, but this is very, very, very little. Even hardly measurable. So when I measure on the LED, it says 0.15. Not even close to what you need to have it burn. So then I wonder, what is the voltage on the main? This should be 5 volts, and then I have of course to change to a limit of 20 volts, and it is indeed 5 volts. Now the mass, I need to measure the mass, which is of course 0 volts, but then the point is that with this I have the idea that I need to point the 5 volts to the pulse width modulation as well, to get at least something running, because in this configuration here with the op amp I had to use that as well, and that was with software pulse width modulation, but now the point is this worked with old pulse width modulation. It only worked when I turned up the voltage, and that is not the point. It has to be turned up by means of pulse width modulation. So what I am going to do now is use a wire, and I just take a wire. I'm not needing this anymore. From the power, and of course I can use this power as well. Everything is power. Not obstruct the view of the camera. So now it is in here in the power, and I add it to the voltage here. So now I should be measuring a lot more. 4, and keeping the light away, the LED isn't burning, so that's no good. And here I'm not measuring anything. Here I am, although not that much either, while here I am. So, and here I'm not measuring anything either. So from one side of the resistor to here there's a drop of 4 volt. Then the question is again, what is on this side of the transistor? Hardly anything. 0.3 volts. So this is a bit of a question. How can that be? How can it be that it is like that? Maybe I should remove that resistor. I think I should. So the program is constantly running. I am now going to remove this resistor, but then I need some wire, and I will use a jump wire for that. Let me use one of these. I'll just have to move these wires one lane. And there you go. However, despite the fact that this motor is running, it's running on 5 volts. So what if I remove the pulse width modulation? It still moves. But if I remove the pulse width modulation wire, you hear the motor change. So if I change now the pulse width modulation, what will happen then? Not much, because it keeps running. I changed the program a bit, just a little bit. So now it's running 5 volts, and once again, if I add or if I use pulse width modulation or not, the motor runs at 5 volts. So this really makes me wonder. 5 volts is apparently enough for this motor to run, despite the 9 volts nominal. And still I can't figure out how the pulse width modulation is influencing this motor. And that is what this whole experiment was about. So the resistor I removed, this one, really gets the voltage down too much. And on the other hand, what about pulse width modulation? How can it be that this motor runs without pulse width modulation while it is a pulse width modulation motor? I tried software pulse modulation for extended time and it didn't matter. And now the hardware pulse width modulation that says, okay, it works for motor only. And now this. Right. I'm not really quite sure where to go from here. I really have to think about it. Then there is also another question. Do I really need a transistor for this motor to actually do something? The simplest way to find this out is to put this wire in this lane, so it actually goes out of the circuit. The clear answer is yes, but it runs at a higher rotational velocity. It runs faster. Here it is a higher pitch. Here's a lower pitch. But apart from that, there really is, it is really not needed to actually use the transistor circuit. On the other hand, does it need also in this case pulse width modulation wire? So I'm going to remove the pulse width modulation wire. It has a slightly different sound. Now it's constant. It sounds a little bit different. On the other hand, the program isn't running either, so I'm starting the program with 150 microseconds pulse. And it doesn't matter if I remove the wire or not. So this wire removed doesn't matter, and this wire straight on the 5 volts or via transistor doesn't matter either. It just runs. Yet when I put it on a power controller that runs 9 volts and I've measured it, it really changes the pulse width between, well, not the pulse width but the frequency of the pulse width modulation between 40 and 220 Hertz. You actually change the rotational speed of this motor. So yeah, what next? What kind of motor is it? Right now, that is a very, very good question. This whole thing works if you change the voltage using the op amp and the potmeter. I've demonstrated that in the past, and if you want to see that, go back quite a few episodes of this series. And now this, yeah, right now I'm clueless. Alright, so it turns out that the motor works at 5 volts, and it doesn't matter if it straight runs at 5 volt or via transistor. The presence of a pulses modulation does not seem to matter either. However, when I put it on a power controller at 9 volts, I can clearly control it. So what I'm going to do is change here a little bit. It should be working, so I say here 4x in, and now I think I should do it like this, in and let's just keep this up, and then here make sure that this is going to 150, making here X, and then say very old-fashioned, X becomes X plus 10. Not quite sure if that will work, but I'm going to try it anyway. And then here say print X is, and then X. Then say here if X is equal to 150, X is 0. Alright, not sure if this is going to work, but let's just check. Alright, quit. Let's verify what is happening. This is a bit odd. Why is it just from 0 to 150? Because in range, that's much better. You can see here how it goes, but it says alright, I can skip this. Doesn't matter, so let's go again. You see the value going up, but there is absolutely no change in motor behavior. And I should really hear something like a pitch going higher or a pitch going lower. Rotational speed going up or going down. And this is not what I expect. So what else? Alright, so so far this doesn't really work, but via this information it turns out that there are 15 DMA channels, direct memory access, and any number of GPIOs per channel. So as a last attempt for this episode, I'm going to change DMA channel, and I will start then with the first and see how this works out. And then is the question, why doesn't it initialize? That's a good one. Alright, let me go back. This does work, and it says channel, GPIO, start and width. So when looking at that, I say, okay, so this is obviously the initialization of channel 0. So if I change this to 1, as I did, then this should be alright. Although here I forgot to clear the channel. So let's do it again. 1, 1, 1. See what happens this time. Goes better. But not as I like. Okay. 2, 2, and 2. Oops, and this is not going what I like. Oops. Nope, not at all. So I need to find out what's going on. And it turns out that I am probably resetting. Well, yes, power down. Ouch. Anyway, as far as this goes, I have no clue why it shut down. This is obviously not ended, and yeah, let's go back to the circuit once again. Alright, after an unexpected shutdown by the Raspberry Pi somehow, not a clue what I did, the motor is still working, which is also kind of unexpected. So when I remove pulse modulation, it just runs. When I remove power, it quits, and when I remove this power, it quits. I still have to try the DMA channel, but from the last few results I figure that won't matter. Last resort is to find out how the motor really works. With that said, thank you for watching. strange, unexpected behaviors. Well, unexpected by me. If you like this video, please subscribe if you haven't done so to my channel. Visit my website for other topics and experiments. If you like my experiments, you may consider to make a small donation to keep this blog and videos going. Also check out my Instagram, and this is certainly to be continued. Bye bye.